Hello, I am Dr. Deepthi and we are looking at different concepts from maths under the heading Decreations Mathematics. In the broad topic of linear algebra, we have been studying what subspaces are. In the earlier episode, we have already defined a subspace, tried to understand the concept of a subspace and seen an example. But there the example was given as it is. In this episode, we will be trying to prove that it is a subspace. So for that matter, let us consider V as a vector space RQ, which is defined over the field of real numbers. Now, if you want to revise the concepts such as vector space, subset, sets, etc., you can refer to the earlier episodes. We have discussed it all in detail. Now here W is a subset of V, such that it consists of all the vectors in R cube with equal entries. So if it consists of three elements W1, W2, W3, all of them are equal. Numerical examples you can see here, 111, minus 54, minus 54, minus 54, or 2 by 3, 2 by 3, 2 by 3. All of them are going to be examples of W. Now we need to show that W is a subspace of V. How will we show it? We need to look at the three conditions. If you recall, we had seen earlier that there are three conditions that need to be satisfied. If A and B are two elements of W, then their addition should also belong to W. That means there has to be closure under addition. Similarly, if A belongs to W and if K is a scalar belonging to field F, then the scalar multiplication Ka should also belong to W. And thirdly, the zero vector should also be in W. So this is kind of a special case of the second condition. So let us try to check all these three conditions. So now we can consider any two elements A and B belonging to W. Since all the entries need to be equal, we can call A to be XXX and B given as YYY. Now what is going to be their addition? We are just going to add the respective components. So if you see here, if you are adding XXX and YYY, X is added to Y. That gives you the first component X plus Y. Similarly, if you add the second component, you get the second component, and similarly with the third component. So as you can see here, we get A plus B, which is X plus Y, X plus Y, X plus Y. So again, all the three entries are equal. So it is belonging to the subset. I will right now call it subset till we prove it as to be subspace, belong to W. That means we have proved the first condition, that if A belongs to W and B belongs to W, then A plus B belongs to W. It is closed under addition. Now consider some scalar K belonging to F. So what is going to be the scalar multiplication of Ka? Simply you will be multiplying each of the element of A with K. So it will give you Kx, Kx, Kx. Again, all the three entries are equal. So this belongs to W. So the second condition, that for every A belonging to W, Ka should also belong to W, is satisfied. And now the third condition of zero vector. If you just take 0, 0, 0, it will definitely belong to W because all the entries are equal. So all the three required conditions are satisfied, and hence we can show that this is indeed a subspace of V. Thank you.